And the properties of exponents. All right, so to begin with, on this one, okay, remember one of the things that we learned was how to deal with a negative exponent. So that's pretty important. So if you had something like 2 to the negative 2, okay, students all the time think that has a negative answer. That's a positive number is what it is. It's just a small number, so remember what we did is we learned how to just change it to that, correct? They're the same thing. And if you did 2 to the second, of course, is 4, so you get 1/4. Okay, if you did this on a calculator, your calculator would spit out a 0.25. So anytime you're doing a number, a positive number to a negative power, that's a positive number. It's just it's just a fraction is what it is. So if I took my calculator and did 2 to the negative 2, like I said, get 0.25. The calculator is programmed to follow that procedure. If we did like 2 to the negative 10, or I'm sorry, 2 to the negative 10, it's not going to give you a negative answer. Look what it's going to give you. It's going to give you something in scientific notation. It's just a tiny, tiny number. So if you had 2 to the negative 10, what that is that's 1 over 2 to the 10th, and then it does that division problem. So it's just a very small number, okay? So what you would do on a problem like this, number 33, is you would start by writing this as 1 over 27 to the 4/3. Okay, if you got a negative exponent, make it positive. Move it to the opposite part of the fraction. Then we're going to apply what we looked at last time. And you want to remember that we learned how to deal with this. We learned how to change that into a radical. Okay, so what that means is the denominator 3 means it's a 3rd root. Okay, and then what you have is you have 27 to the 4th. So that's what we learned, but that's what that really means. A 4/3 power is a cube root of that number to the 4th, okay? So you got 2 choices. You could get your calculator out and do 27 to the 4th, but you don't have to. Most of these problems, if you do it the right way, you can handle in your head. So actually, this is the same thing as cube root of 27, which hopefully you can do in your head, all to the 4th power. Those 2 things right there mean the same thing. Instead of putting the 4 under the radical, you can put it outside. Okay, we did that. Okay, now let's see if we can do this in our head. Tell me what the cube root of 27 is. 3, good, because 3 to the 3rd is 27. So that would be 1 over 3 to the 4th. You could do that in your head if your life depended on it. I know you could. What do? You just multiply. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Or you can even do it this way. Pair them up. 9 times 9 is 81. You could do 3 and 3, the other 3 and 3, so you get 81. So the answer to that problem would be 1 over 81. Okay? Now I do want to show you a little bit here today that this is really an arithmetic problem. It doesn't have any variables in it. So if you want to try this with me, on your calculator you can. So if you have a TI or a pretty good calculator, if I did 27 raised to the negative 4/3 power. Now my calculator kind of automatically puts everything up in an exponent like that. So if you put that in, you would get this, and that's kind of a cool answer. Look at that. It's 0.0123456 and that actually is 89. It just rounded. Isn't that cool? That's got a kind of nice little pattern to it. So anyway, our answer was 1 over 81. So if you did 1 divided by 81, okay, you get the same answer. So you can tell you're right. Okay, you can take your answer that you got and see if it's the same thing. You see what I did? So you can tell you're 100% correct on these kind of problems. What I'm after is, this is the answer I'm looking for, is 1 over 81. I'm not looking for the decimals, but on homework and stuff, you want to check your answer with your calculator, you can certainly do that. Okay, this next problem, now this is a variable, so there isn't anything that you're going to do on this other than just moving that to the bottom like that. So you could write the answer like that. Okay, you're making the negative exponent positive, or if you wanted to, you don't have to, you could also change this to the 5th root of x to the 8th. Or you could even write it like this, 1 over 5th root of x, and the whole thing to the 8th. Those are all the same thing. Really, if you have a variable, you can just stop there. There's no need to go any further with that. Same thing with this 35. Okay, now what you do with this, we learned this last time also, is if your negative exponent's in the bottom, what happens if you move it to the top? and it becomes a positive exponent. So anytime you change where something is in a fraction, then the exponent changes its sign. So the 8/5, you don't do anything with that. That's a number. That's a fraction. Leave it alone. But bring that to the top, then you would have x to the 2/9, and that's all I'd want you to do with that problem. So partially what you're learning to do is go through and make negative exponents positive, like that. Does that make sense to everybody? Okay? All right? So that's what negative exponents are. We talked about that a little bit last time. Now, if you're a STEM major and you're in science, well, you're going to work with scientific notation all the time. That's the most common place where you see negative exponents. Like, let's see, I'm trying to think of something. I think that if you take chemistry, and I'm probably wrong on this, but like if you were looking at the mass of an electron, I know it's something like that. Is anybody a chemistry student currently? Probably not. Are you in chemistry? I'm probably way off, but okay, well, a lot of you are going to get there. So you'll end up, when you're talking about masses of tiny objects, you'll be dealing with negative exponents. Okay, if you're a computer programmer, learning about computers, you'll look at how fast does it take for one operation. Well, you're talking about, I don't know, picoseconds or nanoseconds, something like that. You know what I'm talking about. That's like a tiny number, so it's going to have a negative exponent. So you'll see that. Okay, now what we're going to do with these problems is we're going to get into our properties. Well, I think one thing that I had written on your paper, I said it was kind of similar to this problem. Students a lot of times freak out when they see fractions within an algebra problem, and it's not that hard. What's the answer to x to the 5th times x to the 3rd? X to the 8th. You add exponents. So anytime you multiply variables, you just add the exponents. Okay, then these numbers x have to be the same. So that's actually all you would do in this problem, is you would just do 5/8 plus 3/8. That's it. You just add the exponents. Now, if you're dealing with fractions, if it has the same denominator, what do you do with that denominator? You keep it. Okay, and then 5 plus 3 is 8. So that would be x to the 8/8. But what is 8 over 8? 1. It's 1. So you would end up with x to the 1st. And you don't want to write it that way, you want to write it that way. If you put x to the 1st in my method, I will count you wrong because it's unnecessary. Okay, x is the answer to the problem. See what I mean? So what we're going to be dealing with is problems you've done before, except the exponents are going to be fractions. So you just have to be on track with how to do your arithmetic. Okay, this problem would be kind of similar to z to the negative 2 times z to the 3rd. What would you do if it was that problem instead? What do you do with the exponents? Same thing, you add them, right? So you would just do z to the negative 2 plus 3, that'd be z to the 1st, wouldn't it? So that would be z, yes. What's that? What are you talking about with 2z? I'm not sure. Okay, because remember, are you talking about what I'm doing here? Okay, I'm just adding the exponents. So negative 2 plus 3 is 1. Okay, here's where you get a 2z. If you did z plus z, that's what gives you 2z. And then if you have z times z, that's what? Z to the 2nd. Students a lot of times get that mixed up, and that may be what you're thinking about there. Okay? All right? So anyway, what you'll do on this problem is you're just going to add the exponents. And you can do this in your head if you want to. So we're going to do negative 2/5 plus 3/5. So that will be z to what power? 1/5. Problem done. You don't have to do anything with that either, because the directions to the problem say just write the answer so it has positive exponents. You don't have to change that into a radical like a 5th root. That's all you do. Okay? What's that? Wouldn't be negative, because what you're doing is you're doing negative 2 plus 3. Right? So the 3 is bigger. It's like you have a debt of $2. You give the bank $3. You got money now, don't you? You've climbed out of debt. Okay? All right, this problem right here is similar to this. What if I gave you y to the 3rd over y to the 1st? What's that? What's the answer? Y to the 2nd. What do you do with the exponents if you have a fraction? You subtract top minus bottom, so that would be y to the 2nd. Okay? This one you do exactly the same thing. You do 3/4 minus 1/4, so what do you get? Y to the 2/4. And then what would you do? And you probably reduce it, wouldn't you? So if you have fractions that you want to reduce, then be sure you do that. Don't stop there. So you could reduce that to 1/2, and that's the answer to the problem. Okay, so mostly what we're doing is observation of the properties that we reviewed in class last time. Do you add the exponents? Do you multiply them? Do you subtract them? That's the idea. So it starts off pretty simple. Okay, let's take a look at this one. Now this one I kind of said was kind of similar to b to the fifth to the second. Can you guys tell me what you would do to the exponents in this problem? It's either add, subtract, or multiply. Those are your choices. What is it? Multiply. So you need to be able to recognize that. If you have a parenthesis and exponent inside and outside, then you just multiply. So that would be b to the 10th. Okay, that's it. This problem, you're going to do exactly the same thing. You're going to take b, you're going to take the first exponent 5, and you're going to multiply it by 2/5. Okay? Remember, when you multiply fractions, you go straight across, right? So you have two ways you could do this. If you multiplied straight across, you'd have 10 over 5, correct? But what does that reduce to? 2. So you'd have b to the second. So you can do it that way, or what else could you do? You could have just cross-canceled, right? So you can also reduce before you multiply when you're doing that with fractions. Okay? So what I've done is kind of given you the standard, simplest example of each. Now we're going to put a couple of operations together. So this problem, what I'm trying to do that I think should help students a little bit is just relating this to a similar problem. So I'm just saying, pretend like we had x to the second times x to the third over x to the seventh. Let's just do that problem. I'm just saying, pretend like those fractions are not there. Okay, can you tell me what the numerator would be if you worked that out? X to the what? Fifth. Okay, add the exponents, right? So that would give you x to the fifth over x to the seventh. In your head, can you tell me what the answer to that problem is? 1 over x to the second. Or you could do this. You could subtract the exponents, which would give you x to the negative 2, correct? But then what do you do with that negative exponent? You move it to the bottom, right? Okay, so that would be the way that you would do the problem. And we're going to take exactly the same approach with this, except we have fractions. So what you're going to do is you're going to add those exponents, right? Then once you get that, you're going to subtract like that, okay? Now, if you look at this first step, if you're going to do 3 halves plus 1/3, your fractions have different denominators, so what do you have to do? You have to get a common denominator, right? And while we're at it, we might as well get a common denominator for 2, 3, and 7 all at the same time, because we're going to need one anyway. So one way to do this, okay, if you're not sure, you can always multiply stuff together. If you did 7 times 3 times 2, that would be 42. And if you look at that, everything divides into 42. 2 goes into 42, I think 21 times. 3 goes into 42 14 times. 7 goes into 42 6 times. So that's the smallest denominator you're going to get. Okay? So here's what we're going to do then. So let's write down the problem, and then we're going to have to focus a little bit on how to convert all of these fractions to a common denominator of 42. Okay? So your focus on this is, what do you multiply 2 by so it turns into 42? I already did it over there, 21, right? So you're going to multiply this one by 21 over 21. Okay, you want to write your step real clear so you know what you're doing. Okay, what do you multiply 3 by so it turns into a 42? 14. Use your calculator if you need to. 42 divided by 3 is 14. Okay, what do you multiply 7 by so it turns into 42? 7 times 6 is 42, right? Everybody with me there? Okay, so what we have is we're going to get everything in a correct denominator, then we'll be ready to work out the problem. Okay, so what we're going to have is x to the, let's see, multiply that out. That would be 63 over 42. You can use your calculator if you need to. And then the next one would be, multiply straight across, you're going to get 14 over 42. Okay, like that. Okay, and then here, you're going to get x to the 3 times 6 is 18. 7 times 6 is 42. Yes?
I'm sorry, how did you get 63 over 42?
Okay, what did I do? I multiplied. straight across. 3 times 21 is 63. 2 times 21 is 42. Now, why am I doing that? Because I want the common denominator of 42. So you need to multiply the 2 by 21 so it becomes 42. Okay? Same thing here. 3 times 14 gives you 42. So I'm multiplying the numerator out. If I change the denominator, you got to change the numerator the same way, see? Okay? Okay. Everybody with me so far? Okay. Now, to finish this problem up, what do you do with the exponents in the numerator of that fraction, since it's multiplication? You add them, right? So what you're going to do is you're going to do 63 plus 14, which I think is 77. So that's going to be 77 over 42, right? Okay, the denominator comes down, and that's going to be 18 over 42 like that. Now what do I do? I subtract, right? Anytime you have a fraction, you do the top minus the bottom. So you're going to do 77 over 42 minus 18 over 42. So what's that? I think 77, 67, 50, 59 is what that is. Okay? So your answer to the problem would be x to the 59 over 42. Weird answer, but that's it. Okay? Mostly what you're doing with these problems is you're doing fraction arithmetic. But you're applying your properties of exponents. That's the idea. So if you add fractions, you better get a common denominator if you don't already have one. Does everybody follow that okay? Okay. All right. Now the next one. Let's say that your problem was like this instead. Say that you had r to the 7, s to the 7th to the 2nd. All I'm doing is just saying pretend like you didn't have any exponents. Or no. Pretend like your exponents were not fractions. Okay, tell me what you do with the exponents in this case. Do you add 7 and 2 and get 9, or do you multiply and get 14? You multiply, exactly. So you would do r to the 14th times s to the 14th. How do you know when to multiply exponents, by the way? What do you look for? Parentheses. Exponent inside. Exponent outside. That's how you know. So you're going to do exactly the same thing on this problem. You're going to do r to the 1/7 times 2, and I'll put the 2 over 1. Okay, then you're going to do the same thing with the s. S to the 1/7 times 2. Okay, so what would you get? R to what power? 2/7. Remember, you multiply fractions straight across. No common denominators if you multiply. Then s would be the same thing. That would be s to the 2/7. That would be your answer to your problem. Okay, like that. Okay? You guys kind of get the gist of what I'm doing? I'm doing arithmetic. Yeah, okay, that was just multiplying exponents, nothing to do. Now, let me ask a question. This is important, too. Why would you not go through and just add the exponents now?
Because they're not like terms.
Good, they're not like terms. That's an r, that's an s. If that was also an r, then you would have r to the 4/7, right? But if they're unlike terms, you can't do anything. Okay, so that's important to follow that. Okay, let's do these problems down here. I'll give you a few minutes to work through those, see what you get. And again, all you have to do is work out the problem I gave you, but you can look at this if you find this helpful. I think I wrote on here some similar problems that didn't have fractions as exponents, and for whatever reason, students kind of freak when they see all these fractions. Not supposed to. It's all the same anyway. So you're either going to add, subtract, or multiply. In some problems like 44 and 15, you're going to have to do more than one step to get there. Okay? And I think the handout I gave you guys last time has an answer key on it, so if you get an answer and want to check it and see if you're on the right track, you may do so. First two are supposed to be very, very straightforward. They don't take much work. Multiply. So when you multiply fractions, you multiply straight across. So if you have 1/7 times 2/7, you get, well, that was 2 over 1. That's 2 over 7. Yeah, because that's 2. So if you're multiplying 1/7 times 2, you put the 2 over 1 goes straight across, you get 2 sevenths. So you should have got R to the 2 sevenths, S to the 2 sevenths. That's what I have up on the screen. Okay? Multiply fractions straight across. That's the idea. Okay. And you gotta get a common denominator. You have to. You can do 6 times 5 times 7. That may be what it is anyway. I think that's what you have to do. 6 times 5 is 30, and then whatever 30 times 7.
Yeah.
Okay? Now that one, so you just add the exponents. If you do that, you're not going to have that. You're going to have 1/7. We're getting about your 7. I think you're thinking you would have got a 1, you're forgetting about when you got the second. Okay. See, this one, when you add your exponents, okay, you're doing that fine. Okay, so if you did that problem, you would have x to 4. Now, if you do this problem, do it the same way, except you're going to have to get a common denominator for all those fractions. You can do 6 times 5 times 7 to figure that out and use your calculator if you need to. What you got there is 1/7.
Yeah.
That's good. Right. So the first 2 problems are going to take much work. That one you need to get a common denominator. But see, if you were doing this problem, you would get x to the 11th over x to the 7th. You just add the exponents, then you would subtract.
Oh, yeah. Yeah.
So you need to go ahead and do it the same way, except you've got to get a common denominator. So that's similar to the problem I did for you. Add the exponents. So like if you were doing a problem like this, you would just add the exponents. -2 plus 3 would be 0 first. So that answer would be 0. What you're going to do on this is you're just going to add those fractions. When you add fractions, if they have a common denominator, what do? You keep it, and -2 plus 3 is 1, so it will be 0 1/7. Okay? If you don't have a common denominator, then you're going to hit it. What's that? That's what I did. See, what we're doing is we're adding the exponents. So the answer is 0 1/7. Just like if you have a problem like that, that's what you would do. Okay? Or even if you add. Well, you're just putting it together, you're simplifying it, so it's even about it. But the way to simplify that is to add the exponents. Okay? And then that second one, what you're doing is multiplying the exponents. You get the answers, you check. I think the last page has the answers. Those are okay. Let's see, you're doing okay. So well, the other thing you'd have to do is you'd have to take that to the third power also.
Oh.
So you got to take the -2 to the third, which is -8. Then you're correct, that would be x to 1/2. And then what you'd have to do to finish it up is subtract those 2 numbers. So you'd have to get a common denominator for 1/2 and 1/4. I think the most common mistake is not doing anything with that 2. What are you using as a common denominator? 210. Yeah, 210 should be what you get. Okay? Right? Huh. Well, that's good so far. Okay, that's good too.
Yeah, how do I go about starting this one?
Yeah. Okay, if you were going to do this problem instead, you would do -2 to the third, which is -8, because you do -2 times -2 times -2, which is -8. You'd multiply the exponent. 6 times 3 is 18. Then, what would you do? Subtract the exponent. So the answer to that problem would be -8x to the 14th. Do that problem the same way.
I don't know if you're right or wrong, so.
Just got to deal with fraction arithmetic. That's what makes it different.
I'm having issues today, though, so that's okay.
Oh.
Right, that multiple of 2, so that's.
That was a 59. That might be, let's see. Do 210 divided by 6. I think you were, oh, I know what you did. Did you have, that was a 77. So you got 35. Did you multiply that by 2? What's 210 divided by 5?
Then you're gonna multiply it by 2.
Oh, did you even check that?
Yeah.
See? So that would be an 84.
Yeah.
That's what it did, right?
Oh,
Okay.
I got that.
It's all how you write the stuff out, so you can look at it outside. Yeah, see, if you try to do this simple as well. If you did that, you'd have to do -2 to the third. So if you multiply out -2 3 times, you're gonna get -8. Then if you look at that piece of the problem, that's when you multiply exponents. So that 2 exponents, so that would be x to the 18, then x to the 4. Now you would subtract the exponents, so the answer to that problem would be -8x to the 14. We'll do this problem exactly the same way.
Yeah, I just did
Just
it.
gonna deal with fraction arithmetic. Okay, you got it okay?
Oh, no, yeah.
Okay. Well, try to do the simpler problem first that I wrote at the side. And what you would do is you'd have to do -2 to the third. So if you took -2 and multiplied out 3 times, you'd have -8. Then you would multiply those numbers to get x to the 18. So the numerator would be -8x to the 18. All over x to the 4th, and you would subtract the exponents. You're going to do that problem the same way.
I don't know what the 18 is.
Multiply. I'm looking at this problem. I'm not looking at that. 6 times 3 is 18.
Oh, yeah, that makes sense.
Okay, so let's see. Now, see, when you multiply, if you're multiplying 1 6 times 3,
3 over 6.
you're going to get 3 over 6, which is a half.
But then I have to multiply by 2 to get the constant.
No, you don't. That 2 right there is just a number.
Not that 2. I'm talking about to get the 6 and 4 to 6.
Yeah, you'll have to get a common denominator. So you would start off by having -8x to the 1/2 over x to the 1/4. Now you're going to subtract those exponents. So you got to get a common denominator. You're going to do 1/2 minus 4.
Right. But this was just a 6 and 4. I figured what I had to do was make them all 12.
Well, let's do. See if you've done that. The common denominator between 2 and 4 is 2.
Yeah, that's 6.
No, but we reduced it. See. See what we did? We did 1 6 times 3. I went ahead and reduced it. Okay.
Oh, I didn't think
Now you
about
don't
that.
have to.
Yeah, I just didn't even think about that.
But it's probably the wise way to do that problem because it makes the numbers.
It makes sense, yeah.
The way you're thinking would work okay. If you left it as 3 6,
Okay.
then you'd have to get a common denominator between 6 and 4.
Well, it's 12.
Yeah, and it'd still work. You would just end up having to reduce your answer.
You're right.
Okay, it'll still work.
Oh, you're right. Okay, yeah, that's good.
Okay, all right. Let's see how we did here. Okay, the first one, what you should have done is just added the exponents. This would be one you can do in your head. So what did you get for the answer on the first one? Z to the 1 over 7. That's it. Okay? All right. The second what did you do with the exponents? Multiply. So you should just do r to the 1/5 times 2, and I'll put that 2 over 1, and then times s to the 1/5 times 2 over 1. When you multiply fractions, what do? You multiply straight across, right? So what's the answer? R to the 2/5, S to the 2/5, correct? Okay, so the answer you should have got on this, R to the 2/5, S to the 2/5, like that. Those were real simple to do, that if you know the rules of exponents, there's nothing to it. Okay, now if you do the next one, if you multiplied 6 times 5 times 7, you get 210. And you can do that without a calculator because that's 30. And then 30 times 7, 3 times 7 is 21. So that would be 210. Okay? Now this is where some of you messed up because of the way you were writing your step. So you're going to have to change everything so it has a 210. Okay, so let me get everything written down. And then you can use your calculator to help you a little bit with this. Okay, so basically if you did, if you start with 6, if you divide 210 by 6, let's see, that goes in, 30, I think 35 is if you do that. You can use your calculator. So what that means you would do is you would need to multiply that fraction by 35 over 35, right? Okay, if you do the next one that has a 5 in it, if you do 5 into 210, let's see, that goes, 40, was that 42?
Yeah.
Okay, so that one needs to be multiplied by 42 over 42. Use your calculator to help you with that. Then the next one would be take the 7 and divide it into 210.
Okay, that I think is what, 30,
30.
what was that?
Just 30.
30? Yeah, I can do that in my head. That's the easiest one. So that's 30 over 30 like that. So if you write the step like that, then you're probably not going to make the common mistakes that I see students make all the time. Then you're going to need to just use your calculator if you need to. So that's going to be x to the 35 over 210. Okay, the next one is going to be x to the what? X to the 84 over 210, right? Okay, then the last one is going to be x to the what? 2 times 30 is 60 over 210. Everybody with me there? Okay. Now what you want to do to finish this up is you go ahead and you add the exponents in the numerator, right? So if you add those numbers up, let's see, 84 and 35, what's that, 119? So you would have x to the 119 over 119, 210 over x to the 60 over 210. Then what do? And you subtract the exponents. So if you do 119 minus 60, that gives 59. So the answer to this problem should have been x to the 59 over 210. That's it. Okay? It's arithmetic. Okay, it's an exercise with fractions. You'll get a lot better with your fractions after you work and practice the problems in this section. Any questions about what I did with that? Okay? Okay? Now the next one, okay, what I'm going to do on this one is I'm going to work out this simpler problem at the side. What I'm trying to do with this is show you that the fractions don't make any difference in how you do the problem. It's still the same thing. So if you were doing this problem, you would have to take negative 2 to the third, right? You have to, because that's what the problem says. How do you take negative 2 to the third? You multiply that out 3 times. What do you get? You get negative 8, right? Now, what do you do with this piece of the problem right there? Do you add those exponents or multiply them? Multiply them. How do you know? Parenthesis, exponent inside, exponent outside. You got to recognize that. So that's going to be x to the 18th, then all over x to the 4th, okay? Then what do you do with the exponents on the 18 and 4? You subtract. So that's going to be negative 8 x to the 14th, correct? The problem you're doing is going to be done exactly the same way. You're going to start off by doing negative 2 to the third, which is negative 8. Then you're going to multiply this exponent. You're going to do 1/6 times 3 over 1. And then I'm not ready to do anything with 1/4 yet, correct? Okay, if I multiply this fraction straight across, that would give 3/6. But 3/6 reduces to a half. So you would end up getting negative 8 x to the 1/2 over x to the 1/4. Okay, everybody with me on that? Okay, what do I do with the exponents now? Okay, I subtract them. But if I subtract them, I got to get a common denominator, right? So what is that denominator between 2 and 4? 4. Okay, so what we're going to do is really all you should have to do is multiply this by 2 over 2, so it changes to the right denominator. So then what you would have is negative 8 x to the 2/4, which is the same as a half, x to the 1/4. Okay, now what's the answer to the problem? What did you get? Is there anybody out there? Is there anybody out there? I don't even know who I'm talking about. Pink Floyd, right? The Wall, okay? All right, so 2/4 minus 1/4 is negative 8x to the 1/4. Okay, like that. That's it. Okay? Arithmetic. Properties of exponents in arithmetic. Any questions about what I did on those 4 problems that you just finished? Okay. Now, what we're going to do to finish this section up, we're going to kind of look at how to simplify these expressions that have radicals in it with rational exponents. Now, if I talk about a rational exponent, all that's really meaning is your exponent is a fraction. Okay? So the first thing you got to learn how to do, we talked about this last time, is you got to write this as a exponent. And it goes like this. Whatever is with the x is the numerator. Whatever the root is the denominator. So that problem is the same thing really as x to the 4 over 20. That's what we learned last time. You got to learn how to rearrange those things. Okay, is there anything you can do to 4 over 20? like reduce. There you go. So let's reduce that by 4. You can do that in your head if you want to. That would be 1 over 5. So that is going to give you x to the 1 over 5. Okay, now, I didn't really write the directions on here. You could either stop there, that's okay, or you could change it back into a radical. So if you change it into a radical, where does the 5 go? Does that go under the radical, or is that the name of the radical? That's the name of the radical. Then you'd have x the first. Okay? So you would end up with the answer would just be 5th root of x. You don't have to put x the first because that's x anyway. So what you're doing is changing this to a fraction, the way we learned last time, reducing, then taking it back into a radical. Does that make sense? Okay? If you're going to take calculus one day, you're going to do this kind of thing all the time. Rearrange exponents to radicals and vice versa. Okay? So we're going to do all these the same way. Okay, if you do this one, we're going to start with y to the 28 over 20. Okay, 20 is the denominator because it's the name of the radical, times z to the 25 over 20 like that. That's how you start. Real simple. Okay, can you reduce 28 over 20? Yes, you can reduce that by 4. 4 is the biggest number it divides into those, so that's going to be 7 over 5. So that's going to give y equals 7 over 5. Okay, like that. And then the 25 over 20, you can reduce that by what number? By 5. So if you do that, you would have 5 over 4, and then that would be the answer of the problem. You don't have to write these things back in a radical. That's not the point of the problem. So that would be the answer. So what you're doing on really both of these problems is changing it over to fractions, reducing the fraction, problem done. Okay? Now let me ask a question because I see students do this all the time. Why would you not add the exponents on this problem? Unlike terms. That's a y, that's a z, that means you're done. You can't put those together. These bases have to be the same before you can use any of those properties of exponents. So that's how that works out. Okay, next one, we're going to kind of go like this. Now, what you would want to do with this one is, I'm going to start this by just doing the 6th root of 729. I'm going to do that part, then I'm going to do x to the 2/6. The reason I'm doing it that way is because you could take your calculator and you could take the 6th root of 729. It probably comes out to be a whole number. Whatever calculator you're using, you want to know how to do roots, any type of root. On a TI, I showed you this last time, if it's a 6th root, you put the 6 in first, then you go to the math button, and then you go down, it's option 5 is where it says x root. If you don't have a graphing calculator, you're probably going to have you might have a key that looks kind of like this or something. It might look like that, something like that. Okay, so if I just put in now the 729, then that'll work that out. So that's 3. Okay, notice that if I do 3 to the 6th, I get 729. Okay, so that means what you're going to get is this root is going to turn out to be 3. Then you have x to the 2/6, but what is 2/6 reduced to? 1/3. Okay, so the answer I'd be looking for is 3x to the 1/3 power. So what I did is I went ahead, since that's a number, that's not an exponent, so I went ahead and just took my calculator and did that root like that. That's how you do that. Okay? Okay, I'm going to let you guys do the next 2 problems. Tell me how you would start off the first problem. How would you write that?
6 over 9.
Y to the 6 over 14, and then what?
Z to the 14 over 14.
Okay, and then finish. Okay, you're going to do the same thing on the next problem. It becomes an exercise in changing it over to exponents and then reducing the fractions. Okay, I reduced the fraction. So see how I had a 2/6, 2 over 6. When you reduce 2/6, you get 1/3.
So you don't reduce it by...
Now, what you want to do is you always want to reduce your fraction. So what I did is I divide the top and bottom by 2 to get 1/3. Okay? That's what you're going to do on the problems you're doing right now, is if you need to reduce, then you reduce. Yes?
If we were taking the 729 to the 6th root, wouldn't that just go to the 6th root, make it 3x, and then go to the 2/6?
Well, what I'm doing, are you talking about the previous problem? Yeah, what I'm doing is since that's a number, 6th root of 729 you need to use your calculator on. what you're doing is you're finding a number that you multiply out 6 times that would give you 729. That number is 3. Use your calculator. And then this part of the problem, you just say x to the 2/6. And then that reduces to 1/3. So see, 729 is a number. You want to do the 6th root of 729. It's not an exponent.
The 2/6 is not how you write 2/6 would be the same thing as writing 6.
Yeah, so that's what we're looking at. If you have the 6th root of x to the 2nd, that's the same thing as x to the 2/6. That's what we talked about last time. We worked on that a little bit last time. Okay? So it's just learning how to change the radical into a fractional exponent is what you're doing. Okay, so let's see what we got on this first one. Okay, so if you do 6/14, what does 6/14 reduce to? 3 what? 3/7. Why am I thinking 8? I'm thinking 8 in my head. You're right. Okay, so yeah, that would be 6/14 reduces to y to the 3/7, and then what happens on the 14/14? That's just z to the first, so you don't need to write z to the first. Just write the answer like that. Okay, real simple, just reduce the fractions. Okay, the next one, let's see, 28/12. Well, how do you reduce that? What do you divide it by? Probably 4, or by 2 twice. So that would be, what, 7/3. So that fraction right there is going to go to 7/3. And then 9/12, that reduces by 3. So what do you get when you reduce that? 3/4, right? Okay, so that's going to go to 3/4. So your answer is going to be y to the 7/3 times z to the 3/4. Okay, real simple exercise. Just learning how to change the radical to exponents and reduce. That's it. Okay, does that make sense to everybody? Okay? Okay. All right, we got one more thing to finish up here, then we'll do a break. As soon as we're done with these problems, then we're going to get into the next section here. Okay, so what you're going to do with this one is, first of all, you want to read the directions of the problem. It says, use rational exponents to write as a single radical expression. So your goal on this problem is to have an answer that's just one radical, not a square root. It can be anything. It could be a square root, whatever root. Okay? So first of all, how would you write the 8th root of x as x to a power? What would that be? X to the 1/8, right? Okay, because that's understood to be a 1. So let's write that as x to the 1/8. Okay, how about the square root of x? How do you write that? Students forget that all the time because they don't see the 2 there. You have to understand that if it's a square root, that's a second root. We just don't write it there. Okay, so what that's really saying, the square root of x is really saying that, so it's 1/2. Okay, now your goal is to get this in one radical. So the only way you're going to do that is to make these denominators the same. If you do, then you can put it back under one radical. Okay, so what you need to do is figure out what is the common denominator, the least common denominator of 8 and 2. So what is that? That's 8, right? 2 goes into 8 and 8 goes into 8. So what you're going to do is the 1/8, you're going to leave it alone. What do you multiply 2 by so it goes to 8? 4. So you're going to multiply that by 4/4, right? Okay, it's just like you're going to be adding the exponents anyway. So what you would have is x to the 1/8 times x to the 4/8. Okay, everybody with me so far? Okay, now you can go ahead. Can you add the exponents on this? Okay. Yeah, because the bases are the same, right? Like terms, x and x. So if you do that, you would have x to the 5/8, right? Now, if you change this back to a radical, which is the goal of the problem, what's the name of the radical? What goes there? 8, and then where does the 5 go? Underneath. That's your answer right there. So see, your answer is going to have one radical, and the only way to accomplish that is to make sure that you have a common denominator. Does that make sense? Okay. All right, let me do a couple more here, and then I'll let you do a few, and then we'll take a break. Okay, how do you write the 5th root of x? X to the 1/5, good. How about cube root of x squared? How do you write that? X to 2/3, right? Okay, so if you're going to get that under the same radical, the 5 and 3 have to have a common denominator. So what's the common denominator for 5 and 3? 15. Good. Okay, so we're going to change everything, all the exponents, so that they become a 15. Okay? All right, what do you multiply 5 by so it becomes 15? 3. So you're going to multiply that by 3 over 3. And what do you multiply 3 by so it becomes 15? 5 over 5. Good. Okay, so that's the step that you need to show. So this is going to give x to what power? 3 over 15 times x to the what power? Straight across, 10 over 15, right? Okay, can you add the exponents on that?
Yes.
Yep, because they're like terms. So that would be x to the 13/15. Don't add the denominator, you keep that alone. Now if you write it back in a radical, what's the answer? 15th root of x to the 13th. Good. Okay, so that's how you're going to do that. Same idea. Okay. All right, let me do this last one here. So how do you write 5th root of y? Y to the 1/5. That y is to the first power. How do you write 6th root of y? Y to the 1/6. Okay. Now if you're going to get those under the same radical, the 5 and 6 have to have a common denominator. So what is that common denominator? 30. 5 times 6 is 30. So what we're going to do is you're going to change these things over to 30. So you need to multiply the 5 by 6. So you're multiplying by 6 over 6. Whatever you do to the denominator, you got to do the same thing to the numerator. And then what would you multiply the 1/6 by? 5 over 5. Okay. So when you do that, you're going to have y to the 6/30. Go straight across. And you're going to have y to the 5/30. Okay? All right. Now let's see. What do you do with these exponents? Those are like terms, so what do? You subtract, because it's a fraction like we learned. So that's going to be y to the 6/30 minus 5/30. You just do that in your head. So you get y to the 1/30. Okay, what's the answer if I want you to go back to a radical? 30th root of y to the first, but you don't have to have that y to the first, so you just say 30th root of y. Like that, problem done. Okay, does that make any sense? Okay, all right, let's do these next two problems. Let's just all kind of do the first step together.
Yeah, I'm only one.
54.
Stop it.
Oh, it stopped there?
Yeah.
Oh, we're done, aren't we? Maybe I cut this a little short, didn't I? Oh, I see. I didn't give you, okay, yeah, I did give you 55 in a sense, though, didn't I? Well, I need to be careful on this. I made some changes and forgot to do that then. Why don't you guys go ahead and just do these two problems, like it or not, okay? All right, let's do hold on, let's not do that one. I didn't intend you to do that one. Just do this problem right there. Okay, then we'll take a break. That one's on your handout. That one is number 54, isn't it? Okay, very good. I think that's what I meant to do, was just cut that, because everything's been matching up to now, right?
Yeah.
Yeah, okay. I didn't intend to get that problem. That's right. Now this one's just like the one I just did. What's the common denominator you're going to use? 42. So what's your final answer?
42nd root of 1.
Okay, 42nd root of y. That's it. Okay, so that's the idea. All right, let's go ahead and break till 1 o'clock.